Hi everyone, welcome back to Algebra 2 with Miss B. Today we're going to be going over lesson 13.2, exponential decay functions. So first we're going to state that an exponential decay function is an exponential function with bases between 0 and 1. So here they want us to fill out the table with the exponential functions. So they have f of x equals 1/2 to the x power. So first they provide us that x to the negative 3 when plugged into the parent function is 8. So I'm going to do 1/2 to the negative 2 equals 4. 1/2 to the negative 1 is going to be 2. 1/2 to the power of 0 is 1. 1/2 to the power of 1 is 0.5. 1/2 to the power of 2 is 0.25, and 1/2 to the power of 3 is 0.125. Okay, so that's the beginning table that they wanted us to fill out. So in our parent function, our first reference point is 0, 1, but in an exponential decay function, it becomes a plus k. Okay? In our second reference point, in the parent function, it's negative 1 as our x value, and our y value is 1 over b. For our exponential decay function, it is our x value is at h minus 1, and our y value is a over b plus k. Okay? And for our parent function, asymptote is y equals 0, but for our exponential decay functions, y equals k. So our asymptote is equal to k. So for our first example, they're asking us to use the parent function that is graphed here and g of x to graph the transformed function. Okay, so what I need to do in order to do this is find my first and second reference point. Okay, so my first reference point is h a plus k. So my h value is here. So that's 2, 3, which is my a value, plus k, which is negative 2. Okay, so when I add a negative value, that is 2, so it's 3 minus 2. So my first reference point is 2, 1. Okay, so equals first reference point. Okay, and my second reference point is, it's h minus 1. A over b plus k. Okay, so here our h is 2. So we're going to do 2 minus 1, 3 over our base of 1/2 plus k, which is negative 2. Okay, so, sorry, you can hear my cat snoring in the background. So that becomes 1, and when I divide a fraction, it becomes 3 divided by 1/2 minus 2. Okay, and I'm going to continue over here. So when I divide a fraction, it actually becomes 3 times 2 over 1 equals 6. Okay, so it becomes 1, 3 minus, 6 minus 2, so I get 1, 4. Okay, so this is my second reference point. So I'm going to use a nice bright blue to graph this on my graph. So I'm going to find my first reference point, which is 2, 1. So I'm going to go up to 2, or I'm going to go over to 2 on my x-axis and up 1. Okay. And then I'm going to go to the x value of 1 and up 4 for my second reference point. Okay, so this is 1, 4, 2, 1. And my asymptote in this is going to be y is negative 2. All right, because this is my k value. So here is my asymptote. And when I draw this, it looks like this. Okay? So that is how you do this example. All right. So for this example, I like this bright blue. We'll stick with this for right now. So they give us that g of x is equal to negative 1 over 10 to the power of x plus 2 plus 8. Okay? So when you see this negative here, that doesn't mean that there's nothing there. It's just saying that negative 1 over 10 x plus 2 plus 8. That's what that's saying. Okay? So I'm going to list my values, A, H, K, and B. Okay, so B is 1 over 10, K is 8, H is negative 2, and A is negative 1. Okay, so my first reference point is H, A plus K, which is negative 2. My A is negative 1 plus 8. So that gives me negative 2, 7 as my first reference point. Okay? Reference point. Okay, so my second value is H minus 1, A over B plus K. So my H is negative 2 minus 1. My A is negative 1 over 10 plus 8. Okay? So first I'm actually going to come over here down in the bottom and I'm going to do negative 1 divided by 1 over 10, which becomes negative 1 times 10 over 1, so negative 10. Okay, so I'm going to, in the negative 10, so I'll plug this into so negative 2 minus 1 becomes negative 3. Negative 10 plus 8 becomes negative 3, negative 2. Okay, so that's my second reference point. And what is my asymptote? My asymptote is y equals k, so this becomes y equals 8. Okay, so these are my answers for the second example. So here, for this example, it says find the first and second reference points. All right, so here's my transformed function. So I'm going to list my values. A is 3. B is 1 over 3. H equals negative 2. K equals negative 4. Now remember, the reason that H is negative 2 is because this is a plus 2. So if this was a minus 2, then H would be a positive value. Okay, but since it's plus, it's a negative value. So I'm going to find my first reference point, which is H, A plus K, which is negative 2, 3 plus negative 4. So that gives me a value of negative 2, negative 1. This is my first reference point. Okay. My second reference point is H minus 1, A over B plus K. So H is negative 2 minus 1. Okay. My A is 3 over 1/3 plus negative 4. So 3 divided by 1/3 is equal to 3 times 3 over 1, which is equal to 9. So this becomes negative 2 minus 1, 9 minus 4. So this gives me a value of negative 3, 5. That was my second reference point. Okay? And my asymptote, so y equals k. And in this case, k is equal to negative 4. So y is negative 4. So I found my asymptote, my first reference point, and my second reference point. Okay? So I have one more example, and this says, find the function presented by the graph, or represented by the graph, I apologize. So I have my first reference point, okay, right here, which is negative 3 comma 1 on my second reference point, which is negative 4, negative 2. Okay, so I know that my first reference point is equal to HA plus K. And my second reference point is equal to H minus 1 A over B plus K. Okay, so right away I can find that my value of H is negative 3, since that is my value. Okay, and so if I can say that A plus K equals 1, okay, I can see that my asymptote is 4, so that I know K equals 4. So I can say A plus 4 equals 1, subtract 4, A equals negative 3. Okay. And finally, I can find B by plugging this in. So I can say, I'll do that a little further down here. I'll say A over B plus K is equal to negative 2. Okay. So I have two values. I have my negative 3 over B, my plus 4 equals negative 2. So I'll subtract 4. So I get negative 3 over B is equal to negative 6. Ooh, that's not a good 6. Okay, and in order to cancel the B, I'll multiply by B over 1. B over 1. So this gives me negative 3 equals negative 6B. Then I'll divide by 6. Oops, sorry, not B. I'll divide by 6, divide by negative 6. So my B is equal to positive 1/2. Okay? And that is the values. So I can write my parent function as g of x equals a, so negative 3, times my base, which is 1/2 x plus 3. This is a little tight. That's a little tight. Plus 4. Okay, and that is my transformed function. And that is how you do exponential decay functions in Algebra 2. If you have any questions on this, please feel free to send me a message on the Remind app or text me on Google Voice or send me an email. You'll have a comprehension check on this tomorrow. Or if you see this today, then it'll be today. All right, I'll talk to you guys soon. Bye-bye.